This segment is on atoms. An atom is the basic chemical building block of all matter. An atom is the smallest stable unit of matter. All living and non-living things are made of atoms. Atoms are composed of subatomic particles. The three subatomic particles that help us to understand the chemical property of matter are protons, neutrons, and electrons. Protons and neutrons are similar in mass, but protons have a positive electrical charge. Neutrons are electrically neutral or uncharged. Electrons are much lighter than protons and have a negative electrical charge. The protons and neutrons are located in the center of the atom, called the nucleus. The number of protons and neutrons in the nucleus determines the atom's mass. The mass of the human body is determined by the sum of all the masses of all the component atoms. Atoms normally contain an equal number of protons and electrons. Hydrogen, which is the simplest atom, contains one proton in its nucleus and one electron that orbits around the nucleus. Hydrogen does not usually have a neutron in its nucleus, but all atoms other than hydrogen have both neutrons and protons in their nuclei. Electrons orbit around the nucleus at a very high speed within a spherical area called the electron cloud. This is also called the electron shell in a two-dimensional picture. The electron is negatively charged and is attracted to the positive charge of the proton, so it stays in this electron cloud because of the electrical force. An element is a pure substance composed of atoms of only one kind. A specific element will have the same number of protons. Only 92 elements exist in nature, and 24 other elements have been created in research laboratories. Each element has a chemical symbol, which is an abbreviation. For example, O stands for oxygen, N for nitrogen, C for carbon. An atom of a specific element can have different numbers of neutrons in the nucleus. Two atoms that have the same number of protons but different numbers of neutrons are called isotopes. The mass of the two atoms or isotopes will be different. Hydrogen, for example, has 3 isotopes. Hydrogen 1 with 1 proton and 1 electron, hydrogen 2 with 1 proton, 1 electron, and 1 neutron, and hydrogen 3 with 1 proton, 1 electron, and 2 neutrons. Some isotopes are unstable and their nuclei may break down spontaneously into subatomic particles. These isotopes are called radioisotopes, and the breakdown process is called radioactive decay. Strong radioactive isotopes are dangerous because their emissions can break molecules apart and destroy cells, which is extremely damaging to living tissues. Weak radioactive isotopes are used in some diagnostic procedures. Nuclear medicine uses radiation to provide diagnostic information about the functioning of a person's specific organs or to treat them. Radiotherapy can be used to treat some medical conditions, especially cancer, using radiation to weaken or destroy particular targeted cells. Tens of millions of nuclear medicine procedures are performed each year, and demand for radioisotopes is increasing rapidly. Atoms are electrically neutral because for every positively charged proton, the atom has a negatively charged electron. Within the electron cloud, electrons occupy different energy levels that are organized into concentric rings or electron shells. The first electron shell is closest to the nucleus and can only contain a maximum of 2 electrons. The next 2 electron shells can hold up to 8 electrons. The first electron shell must be filled with 2 electrons before electrons enter the second shell, and the second electron shell must be filled with 8 electrons before any electrons can enter the third shell. The outermost electron shell or energy level of an atom is called the valence shell. Atoms with unfilled energy levels are unstable, and they will react with other atoms in an attempt to fill their electron shells. Atoms with a filled outermost energy level are stable and will not readily react with other atoms. For example, a hydrogen atom has only 1 electron in the first energy level. Because the first energy level is not filled, hydrogen can react readily with other atoms. Hydrogen is one of the most important atoms in the body because it can interact with other molecules to form larger structures. A helium atom has 2 electrons in its first energy level, and since this energy level is filled, the atom is stable and will not react with other atoms under normal conditions. Lithium has 3 electrons. 2 of these electrons fill the first energy level, and the third electron resides in the second energy level. The second energy level is unfilled, and lithium will readily give up this outer electron, so it will only contain 2 electrons in the first energy level and thus be considered stable. Unstable atoms will tend to give up their electrons if there are fewer electrons in their outer electron shell, and will be more apt to accept electrons if there are more electrons in their outer shell in an attempt to become stable.